Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore headless services in Kubernetes. We will learn what are headless services, why headless services, the concept of headless services, and towards the end of this video, I will also show you a practical demonstration of headless services in Kubernetes. It's definitely going to be interesting. Make sure you watch this video till the end. Now, before we learn headless services, let's quickly recap what exactly is a service in Kubernetes. The primary responsibility of a service in Kubernetes is to perform service discovery. What does that mean? Let's say there is pod A which wants to communicate with pod B. Imagine if pod A talks to pod B using the IP address of pod B. You know, in Kubernetes, pods are ephemeral in nature, just like Docker containers. They can go down for n number of reasons. It can be because of lack of resources, or it can be because of any crash loop backoff. In that case, if you create pod through deployment, of course, replica set will create a new replica of the pod. However, this new replica of the pod will not come up with the same IP address. It's very rare that it might come up with the same IP address, but most likely it won't. In this case, communication from pod A to pod B will fail. So any request that pod A sends to pod B will fail. Now this can be solved by using a proxy in Kubernetes, which is called Kubernetes service. So for pod B, you will create a service, and this service does not identify pod B through the IP address, but it will use a concept called labels and selectors. So basically in the service configuration, you provide a selector which queries for the pod using the label associated with the pod or using the metadata associated with the pod. This way, pod can go down n number of times. IP address of the pod can change n number of times. Still, service will identify the right pod. Now, this mechanism is called as service discovery. So this way, requests from pod A are always sent successfully to pod B. Apart from this, what service also is capable is load balancing. If there are multiple replicas of the pod, let's say replica 1, replica 2, replica 3, and replica 4, requests from pod A are balanced between multiple replicas because not only proxying, service also takes care of default load balancing, which is round robin load balancing. So requests from pod A are sent to different replicas of pod B if they exist. If there is a single replica, requests are always sent to that single replica. If there are multiple replicas, requests are balanced between multiple replicas using the service. Of course, I'm not going into the detail because if you want to understand in detail, when a service is created, a endpoint resource is created by Kubernetes. This endpoint resource is watched by kube-proxy. Endpoint has the pod IP addresses associated with the service. Kube-proxy looks at the endpoint and updates IP tables. IP tables typically take care of the networking. So kube-proxy tells IP tables in layman language, if request comes to cluster IP of the service, follow the request to the or forward the request to the pod IP addresses mentioned in the endpoint. So now anybody who tries to hit the service IP address or service DNS name, IP tables forward that request to the pods. Now this is technically internal communication, how it takes place. But overall, if we go back in Kubernetes, service acts as a proxy, which does service discovery as well as default load balancing. Now, Abhishek, if everything is perfect, what is the need for headless service? Now, this is a very important question. Things get difficult when we deal with stateful applications on Kubernetes. Now, this is perfectly fine when you are dealing with stateless applications. But imagine if I take the same example where there is pod A. Imagine pod A is a backend instance or a backend application. And there are multiple replicas of a MySQL DB instance. Let's say this is MySQL 0, MySQL 1. So you have created two replicas of MySQL instance using a stateful set in Kubernetes. Now imagine if you create a service, requests from pod A are balanced between two replicas of the stateful application, which is the DB application. This is a huge problem. Why? Let me give an example. So pod A or client sends a request to pod A. The first query is to create a new employee in the employees table. Of course, this is a vague example, but you will understand it much better with this example. So client sends two requests to backend. The first query is to update employees table by creating a new employee. And second query is to get all the employee details from the employee table. Now imagine if these two requests are sent to service, request 1 is sent to stateful set 0 or replica 0, and request 2 is sent to this replica of MySQL. Volume associated with this MySQL DB will be updated with the new employee, but because request 2 is sent here, now when the get query is performed, it will send the information back, but the response that it is sent will not have the new employee that is created on the replica 0, because the volume associated with it will have the information, whereas this volume will not have the information. This is tied to the instance. So this becomes a problem with the stateful applications. What becomes the problem? Proxying as well as load balancing of the services. But Abhishek, then how does this thing work? So when it comes to stateful applications, you use a concept called headless service. So what is headless service? Headless service, unlike the traditional services, the ones that you create with cluster IP, node port, unlike that, headless service does not perform proxying. In fact, a service is created which will just assign the DNS names to the pod. So every replica of the pod is created with a DNS name so that pod A can directly communicate with the replicas of the pod through the DNS name. Now, if the DNS names are assigned, it doesn't matter if the IP address goes down, pod goes down, a new replica is created with a different IP address, it does not matter because pod A will communicate with a specified replica of pod B through the DNS name. Now, who assigns this DNS name? This is assigned by the headless service. Unlike traditional service, it is not proxying, but it is assigning a DNS name, basically DNS A record, to replicas of the pod, so that pod A or the backend instance can communicate with a specified replica of the MySQL DB instance. Now, if there are two replicas of the pod, right? So this is 0 replica of pod A. This is 1 replica of pod A. Now, this replica can talk to MySQL 0 and this replica can talk to MySQL 1 using the DNS name. So no matter how many times this replica goes down, it doesn't matter. Always the requests from pod A are only sent to this particular replica of the pod, right? So pod A, replica 0, MySQL, replica 0. Pod A, replica 1, MySQL, replica 1. So requests are always sent from here to MySQL 0 and requests from here are always sent to MySQL 1. You can also have MySQL 2, which is only for the backup purpose. So this way you can restrict any requests that are sent to MySQL 2 and you can have active passive configuration. These two MySQL instances will be active and this will remain as a passive instance. So every time it takes a backup from these two active instances and this will be maintained as a backup. You can also achieve these kind of things with headless service. Overall, the primary purpose of headless service in Kubernetes is not proxying and load balancing, just like the traditional Kubernetes services, but its responsibility is to assign a DNS name to the pod so that anyone who wants to communicate with a particular replica can talk to it with a dedicated DNS name, just like DNS A records. Now let me show you the same thing through a practical example. So what we'll do, so I have a Kubernetes cluster, kubectl config current context. So I'm using a Minikube Kubernetes cluster. Of course, you can use Kind Kubernetes cluster or you can go for any cloud provider instance as well. First of all, I will create the headless service. Now there is a catch here. When it comes to headless service, as I told you, it is working with DNS. So it is always a good practice to create headless service first. So I will copy the configuration. I will also share the GitHub link in the description so that you can also use the same example. Let's call this as headless svc.yml. So this is headless svc. As you see here, cluster IP is mentioned as none. Only when you provide cluster IP as none, Kubernetes detects this as a headless service. Okay. And selector is app MySQL. So when we create a stateful set, we will provide label as app MySQL. Okay, let's go ahead. Stateful set dot YML. So I will copy the configuration. Stateful set. Service name is MyDB headless service. It doesn't matter. You can provide anything that you want. Replicas as 3 and label is app MySQL. Right? So this is the pod label, app MySQL. Let's use the latest version of MySQL, or you can use the 5.7 as well. Okay. Now let's go ahead. kubectl apply -f. First we will apply headless service. Then we will apply kubectl stateful set.yaml file. Okay. So let's watch for the resources. kubectl get all -w. Okay. So stateful set is created 3 by 3 and service is also created. Where is the service? Yeah. So MyDB headless service. Perfect. You can see there is no cluster IP. This is what I was talking about. So there is no cluster IP for the headless service. It cannot even proxy. Now let's try to see if as I mentioned before, each pod of the stateful set will get a dedicated DNS name. But Abhishek, how will I know what is the DNS name? It is very simple. So the DNS name will be MySQL stateful set 0 dot the name of the service, which is MyDB headless service dot namespace, which is default dot svc dot cluster dot local. So svc dot cluster dot local is part of the DNS name. So usually you just provide the namespace and the service name. But when it comes to headless service, pods get the DNS name, which starts with name of the pod, which is MySQL stateful 0 dot MyDB headless service dot default svc cluster dot local. Now, any pod or any application, in this case backend, if it wants to talk to the MySQL 0 instance, it can hardcode or within the config map, this DNS name can be mentioned. We can also quickly check this. So because this is a minikube cluster, either I can perform minikube SSH and hit this particular URL, or we will just run a dummy backend instance. So what I'll do is I will use this command kubectl run-it. I'm using a busybox image as the backend application. I'll share this command as well. When you look at GitHub link in the description, along with the manifest, you will also find this command. So this is the busybox container that I'm running. Just assume it as the backend pod. And I'm running ns lookup followed by the same URL that I mentioned. MySQL stateful 0 MyDB headless service default svc cluster dot local. Now when you run this, you should see this DNS name should be resolved to the pod IP address. Which pod IP address? It should be resolved to MySQL stateful 0 pod IP address. Let's see if it got resolved or not. How can we check? Let's run kubectl get pods -o wide. Stateful set 0, which is 10.244.0.15. Abhishek, let's quickly restart this particular pod, right? So what I'll do is I will just do kubectl delete pod followed by MySQL stateful set.0 -0. This is the default namespace. So let's run this command. Okay. So it is deleted. Quite obviously, IP address might change. Yes, it is changed to 10.245.0.15 to 10.040.19. Okay. Now let's run the same command again. So I will again create a backend instance and I will try to run ns lookup on the DNS name. Now, if the DNS name is 10.244.0.19, you understand the concept of headless service. It created a DNS which maps to the IP address. Okay, let's see if it will be the one that we're expecting. Perfect. Now, this way, the problem of service is addressed by headless service. Especially if you're working with stateful services such as database or Redis, headless service needs to be created for it. So when you create a stateful set, instead of creating a regular service, create headless service. What happens again, before I conclude this video, I will repeat this. Generally, pod A communicates with pod B through service because service is assigned with a DNS name and requests from pod A are sent to service. Service identifies pod B using labels and selectors. So pod A talks to the DNS name of service. But in stateful applications, as I told you, this does not work because the default load balancing of service, is the problem. Instead, pod A will directly communicate with the DB instance or a particular replica of the DB instance using DNS name assigned to the pod. But how DNS name gets assigned to the pod? You will create something called headless service, and this headless service takes care of configuring DNS name for the pod. So now pod A can directly communicate with pod B or MySQL replica. So this is the concept of headless services in Kubernetes. I hope this is clear. In case you still find it difficult or there are any questions, let me know in the comment section. I'll be more than happy to answer your queries. Make sure you perform the demo. Only then you will understand the concept of headless service better. Look at the description. You will find GitHub link. See you all in the next video. Take care. Bye bye.